The primary objective of optimization is to identify the optimal allocation option. In this process, operators typically generate a range of solutions with diverse performance-to-yield ratios. Subsequently, the manager selects the optimal solution, for example, solution 39, taking into account factors such as the current company inventory, market conditions, and others. Then the polisher can work on the stone, following the selected plan directly. Creating these allocation options requires the ability to control the performance within the obtained solutions. There are 3 levels of performance control. The classical approach involves defining independent range limits for a set of parameters, centered around known proportions with high performance. In this context, it is assumed that a broad parameter variation range results in higher yield, and a narrow variation range gives solutions with higher performance. Let's consider the following example. Solution 1 represents a fixed-form solution based on reference proportions, indicated by a red star. Solution 2 is a recut solution created using an appraiser with narrow range limits. Its performance is comparable to Solution 1. Upon expanding the range limits, the difference in performance between the best and worst cuts within this range grows rapidly. Frequently, cuts with the highest yield correspond to performance levels much lower than those of the reference cuts. This is evident in Solution 3. It sits on the boundary of the crown slope range, exceeding 1 carat in weight, but exhibiting low performance. With this approach, it is practically impossible to achieve high yield and performance simultaneously. Consequently, the allocation results are usually utilized as target weight guidelines. And the beauty of the diamond largely depends on the skill and expertise of the polisher. The second approach incorporates sweet line control into the appraiser with range limits. For further details, refer to the dedicated video explaining the sweet line method for a round brilliant cut. Sweet line controls the deviation from the optimal combination of crown slope and pavilion slope. It preserves performance and, when working within broad range limits, also increases yield. However, in fancy shapes, there are many other parameters that create a significant impact on performance even for proportions with fixed slopes of the main crown and pavilion facets. As an example, let's compare a set of princess cuts that differ only in the slopes of the chevron facets, with all other facets being identical. It is evident that performance varies dramatically with chevron's modification. One can see princesses with EX to GD brilliance in this set. Let's compare models of princess cuts with high performance and princess cuts with lower performance. We see that the crowns are identical. The main facets of the pavilion's first and second tiers are also the same. The variation in performance for these princess cuts is determined by the difference in chevron slopes. The efficiency of the sweet line approach for fancy cuts is constrained by the multitude of parameters that influence performance. The third approach amplifies the appraiser's capabilities by introducing control over combinations for a comprehensive set of parameters, referred to as grid, alongside the existing range limits. For each parameter combination, a performance metric is calculated, leading us to term this parameter control module Performanceware. GIA Facetware represents a type of Performanceware appraiser designed for round brilliant cuts, with control over combinations set for 6 parameters. For fancy shapes, Performanceware appraisers typically require specification of 8 to 10 parameters, encompassing considerations like girdle ratio, slopes for additional tier facets, chevron facets, etc. In the schematic diagram, parameter combinations resulting in high performance are depicted in green. By employing a combination of MyCut and Performanceware, solutions with both high performance and yield can be achieved while working within a wide range limits. Let's compare the allocation results by the classical MyCut plus Sweet Line Appraiser for Princess 3S and the MyCut plus Performanceware Appraiser for Princess 3S Performanceware. We will employ 23 single plus first Smart Recut preset for the allocation. Subsequently, we'll upload the obtained solutions to Cutwise to evaluate and compare their performance. The solution obtained with the Performanceware appraiser exhibits a 1% higher weight and 4% increased brilliance compared to the solution obtained with the MyCut plus Sweet Line appraiser. Switching to a larger media size for a visual comparison, it becomes evident that the Performanceware solution is brighter both under the table and the crown, displaying higher brilliance. Let's compare the parameters of these solutions using comparative report to understand the differences between them. Access the comparative report through the dedicated button on the stone page. The main parameters of these solutions are very close: crown slope delta 0, pavilion slope delta 0.03 degrees, table diameter delta 0.26%. However, the performance significantly differs. Why does this occur? This difference arises because the performance of the princess cut is influenced not only by the main parameters but also by additional parameters, such as crown side facets, star facets, chevron facet slopes, etc. These solutions notably differ in these additional parameters, as highlighted by the color indication. Let's keep all the main princess parameters constant and examine the 2D section for additional parameters: crown corner slope and pavilion chevron slope. The diagram illustrates a total of 18 combinations between these parameters along with their corresponding brilliance metrics. To enhance clarity, we will highlight areas with high, medium and low brilliance values on the diagram. In Princess 3S, the MyCut Plus Sweet Line Appraiser controls additional parameters solely through range limits. This allows for any combination of these parameters within the specified ranges, resulting in a higher likelihood of obtaining a solution with average performance. In the present case, the solution based on range limits falls within the designated area. Conversely, the Princess 3S Performanceware Appraiser precisely regulates combinations of both main and additional parameters using the grid. Only combinations that yield high performance are presented as solutions. In this particular instance, the Performanceware solution employs one of the optimal combinations of crown corner slope and pavilion chevron slope. The Performanceware technology facilitates the acquisition of solutions with both high performance and yield concurrently. These solutions serve as direct polishing plans and are ready for execution by the polisher.